All right, let's get started. Okay, so today we are working on the chain rule. We are looking at how do we take a derivative that has a function inside of a function. Essentially, we're looking at composition functions today. Okay, so we have all the basic rules that we need. The chain rule is now essentially a compound rule. So here's a function given to us, capital F of x is the square root of 2x squared plus 3. So what we're going to do is we're going to use substitution in order to figure out the derivative. We're going to take the inside and call the inside function u of x. So f of x is now the square root of u, which is a much simpler function that we can deal with. All right, so fu, haha, big chuckle, come on. Thank you. Fu is going to have, we're going to use the regular like power derivative, power rule, sorry, to take that derivative. But then we also need to be able to take the derivative of the inside function. And again, here we have a polynomial, which we know how to do. We're just going to do the power rule plus the addition rule as well. Okay, so when we do the chain rule of a composition function, so we have an outside function and an inside function, the rule is you take the derivative of the outside without changing the inside, and then you multiply it by the derivative of the inside function only. Okay, so derivative of the outside, inside unchanged, multiplied by the derivative of the inside. Okay, so it's essentially a stacked derivative. So let's do the actual example. Okay, I'm breaking this up into two functions. F is square root of u. In other words, f is u to the power 1/2. So f prime is 1/2 u to the negative 1/2. My other function u is 2x squared plus 3, and u prime is 4x. 3 is a constant, so the derivative is 0. And now I put these together. So capital F prime, the original function, is f prime of u unchanged times u prime. So I just need the bottom two. F prime is 1/2 square root of u. So I just need to put u in here, 2x squared plus 3. Multiplied by u prime, 4x. And simplify where you can. This is 2x over 2x squared plus 3. Did I do that too quickly, or can you follow that pretty easily? Okay, so we substitute u or any other letter you want. Look at what is on the outside of the function and just do the derivative of the outside. Then look at the inside, take the derivative of the inside and multiply by the derivative of the outside. Okay? Let's take a look at example 2. Here they've done the substitution for us. We are given that the function y is a polynomial based on, or that depends on the letter u, and the letter u is a function that is also a polynomial. So it's a polynomial inside of a polynomial. So that means when I find f prime, this is going to be y prime of u times u prime, and I want to evaluate it where x is 1. The evaluation piece happens at the end. Okay, so let's do this. Y prime is 10u9 plus 5u to the 4, and that's it, because 2 is a constant. And then u prime is 1 is a constant, it goes away, negative 6x. So f prime is 10 bracket, I'm substituting u as is, 1 minus 3x squared to the power 9 plus 5 bracket 1 minus 3x squared to the power 4. So this is this is y prime. I'm going to put big brackets around it, and now I multiply it by u prime. Should have put a negative in there. Oopsie, sorry. Multiplied by negative 6x. And if I was not evaluating it, I would then distribute and simplify, collect terms, blah, blah, blah. But because I'm evaluating it at 1, I'm just not going to bother with the simplification. I'm just going to go ahead and wherever I see an x, I'm going to put a number 1 in, and that'll just make my life easier. Right? So this is going to be 10 times 1 minus 3 to the power 9 plus 5, 1 minus 3 to the power 4, times negative 6. So this is 2 to the power 9, and then this is negative 2 to the power 4. Can you guys grab a calculator? Tell me what you get. It's going to be a big number because we've got lots of big exponents here. Big number. Is it 2 to the power 9 or negative 2 to the power? Negative 2 to the power 9. Thank you so much. Yes, there's a calculator right behind you, my friend. In arm's reach. Okay, while you guys are calculating this, I'm going to show you an alternative method to do this. What you could also do is evaluate u prime, or sorry, oh, I keep saying it the wrong order. Y prime of u at 1, and then u prime of 1, and then multiply them together. It'll give you the exactly same answer. So find u of 1, put it into y prime, and then multiply it by u prime of 1. Maybe I'll do that for the next example. Oh, so close, but so wrong. Try again. Should not be negative. 30,240. 30,240. Yes. Okay. Example 3. What is the outside function? Sine x is the outside function. X squared is the inside function. So this is in, this is out. What about part B? What's another way that I can write this? Sine x all squared. So my outside function here is the squared, a polynomial, and my inside function is sine x. And you're going to need your formula sheets today. So the square is the outside function, and the sine is the inside function. Okay, let's do the derivative. Y prime equals, what is the derivative of sine? Just cos. So this is cos. The inside is unchanged, right? X squared. Multiplied by the inside function derivative, which is 2x. So done. Can do this in my head. Yay. right? So derivative of sine is cosine. So the inside piece stays with the cosine. And then the derivative of the inside is 2x, and we multiply it by the outside derivative. Okay, let's see. Can we do this one in our heads? What is the derivative of the outside function? Nope. 2 times the thing that it's squaring, right? So this is 2 sine x. And what is the derivative of sine x? Cos x. Done. Okay, so the outside function here is just u squared. So it's 2u. Inside doesn't change. Okay, so what we have just done are examples of the power rule combined with the chain rule. Does that make sense? We have done a few examples here. We can do a few more. I might skip over some of these because I am confident you can do them. I would like to do example 6 together. Example 6, this is a chain rule combined with chain plus, which is called the quotient. So this is chain and quotient rule. So my outside function is the power 6. My numerator is a polynomial and my denominator is a polynomial. This is going to be a little bit more complicated, but will reduce to a nice cute function. Okay, my outside function is what? 6 times the stuff, 2t minus 1 over t plus 2, all to the power 5, right? So this is my outside function derivative without changing the inside. Then I need to multiply it by the derivative of the inside. I'm going to need some big brackets here. So using the quotient rule, remember quotient rule is derivative, numerator prime, denominator, numerator prime, numerator, denominator prime over denominator squared. So my denominator is going to be t plus 2 all squared. Can you take a moment to write down what the numerator is going to be? Hello, Gordon. Hi. No worries. Yes. Sure. About like 10, 15? Yeah. Okay. Sounds good. All right, thanks. Bye. All right, can someone read out what the numerator would be?
2 times t plus 2.
2 times t plus 2.
Minus 2t minus 1.
2t minus 1. Oh, just as is. Yes, perfect. Wonderful. Okay, let us simplify this piece. S prime is 6 bracket 2t minus 1 over t plus 2 all to the power 5. And what is in the bracket? Can we distribute and collect?
Yeah.
What's going to be in the top?
2t cancel.
Yep, and then t plus 2 t squared. Okay, this is sufficient. I'm going to show you how to make it even simpler and cuter, okay? Notice that the numerator is a constant, which we can pull out with that. Can we see how I can do that? I can just make this 30. And then what I'm going to do is take a look at what's left in this numerator here. 2t minus 1 to the power 5 over. Also notice this denominator and this denominator is the same. So I can put them together. What would make sense for how I put them together?
The power 7.
To the power 7, yes. Why is that true? Yes, this 5 applies to both the numerator and the denominator. And when we multiply two things with the same base, the exponents add. So this is fully simplified and way cuter, right? Okay. Example 7. I need two rules. Which ones am I using? Product rule and chain rule. Product rule and chain rule. I'm going to do this one quietly. I want you to work ahead of me, okay? A reminder that the product rule is f prime g plus fg prime. Okay, so I'm going to give you guys a quick head start. And then I will catch up. This one, unfortunately, does not get very cute at the end. If you're not quite sure how to start, check out what I'm writing. You can use substitution to figure out how to use the chain rule. You're going to need to do chain rule first. And then you should be able to put it all together. Like I said, this is expecting a bit of an ugly answer.
Where did that 2x come from?
In the small f prime. So outside function brings the 3 down, and then inside function is from the x squared. So I brought the 3 down, so the bracket is now to the power of 2. And then the derivative of the inside, what's the derivative of x squared plus 1? 2x, and then the 1 goes away because it's a constant. You still look a little not sure. You got it? Okay, perfect.
You're supposed to add the 1, right?
I would add, I did start by adding, but this gave me a -3. So that's why I had to change it to negative. Yeah, the most common error when doing chain rule is usually forgetting either a negative sign or maybe missing a term. And the product rule is kind of one of the uglier ones because it doesn't really simplify very nicely. Yes, sir.
sides together, so it's 3 times the first term and then 4 times the second term, and then bracket it.
If you did that, you would not get two terms separate. You would get a long product of terms. And because this is a multiplication sign, you need to break it into two functions and then the derivative is going to be in two terms because the product rule has two terms in it. Okay, any further questions about this example or can we go on to the next one? Yes. You could take common factors out. You could take an x squared plus 1. You could take a 6 out. And you could take a 2. Yeah, okay, let's factor it fully. What can I pull out? I can take a 6. I can take an x squared plus 1. How many of them? 2. And 2 minus 3x, 3 of them. And I could be left with 2 minus 3x minus 2x squared plus 1. You could distribute, collect like terms. You could certainly simplify it a bit more, but you're still going to end up with two terms. Unless you evaluate it at a point, you're usually going to get two terms when we work with the product rule. Okay, I'm going to skip over to this is a conceptual question that if you understood how to do example, the one with the sign, where's our sign? If you understood example 3, then example 8 is exactly the same. It's just giving you a generic function. Okay, so look at example 3. I will post the full answer key for all these examples a little bit later on. I just want to make sure that we're doing the harder ones together. Okay, example 9. It's beautiful, isn't it? So let's rewrite this in a way that is a little bit easier to look at. So instead of the square roots, I'm going to write them as powers. Okay, and you can kind of substitute from the inside out. Let's say that U is the little square root. Oops, I was supposed to write that as a power. And then I can substitute one more time and say V. So this is like a function in a function in a function. It's like inception. You could also, what's another way I could look at this? I don't think there's a better way to look at that. Maybe? What do you think? Let's give it a go. Yes. How would you do that when your power function is in a fraction? Right? It's a bit trickier. Yeah, if that was a squared instead of a 1 over 2, you could certainly expand it and then just treat it as a polynomial. Yeah, absolutely. Okay. Y prime is going to be V prime times U prime times X prime. We start on the outside and work our way in. So let's do this ugly thing. What's my first derivative? 1 over 2 v to the power negative 1/2. Okay, so that's the first one done. Multiplied by the derivative of this part. Not quite the same thing. It's 1 plus, almost. It's a 1/2 there. So my power is 1 over 2 u. So the power of negative 1 over 2. Okay, and now I'm focused on just that piece there. What's that derivative? 2x. Okay, this is not, however, my final thing. Right now I have to substitute what are v and u in here. So final answer is 1 over 2 times 1 over the square root of vx plus x squared plus 1 to the 1/2 times 1 plus 1 over 2. What is u? X squared plus 1 times 2x. Where can I simplify? I see a 2 in the numerator, 2 in the denominator. That can go away. Unfortunately, this does not get any prettier. I mean, you could, again, try different things, but I just want to get us doing the actual exercises of it all. So this is x squared plus 1 times 1 plus 1 over 2 square root x squared plus 1. So not pretty, but not a ton of work, right? As long as you can kind of see where the inside functions are and start on the outside and work your way in, it's not too bad, right? Okay, any confusion about how I did any of those examples? Okay, let's take a look at some exponentials. Look at example 10. What's my outside function? What's my inside function? E is the outside function. Right, so f prime is e to the x, u prime is cos. So y prime is e to the sine x times cos x. Done. Okay, I hear you guys saying that I messed up. Please tell me, where did I mess up? You're trying to understand what I did. Okay.
So for when you get b prime has u prime has x prime, right?
Mm-hmm.
What so is x prime is x squared plus 1, right?
Yes.
But is u not x squared plus 1?
Sorry. Hold on. U is here. Maybe I should color code it better. Yeah. Okay. U. You want me to restall and start from scratch? Oh my gosh. Okay. We'll do it on the board. Okay. because doing it on the screen sometimes is not super helpful. Okay, can we come back to this one? Okay, exponentials. Outside function, e to the x. Inside function, sine x. Sine x is in the exponent. From a day or two ago, we said that the exponent rule or the derivative rule for e to the x is just e to the x. So this is what our function is. If I were to color code it, yes.
I have doubt in this question. Why is sin x not the outside function? Why is it ex?
That is a good question that I have an answer for. I just have to remember what my answer is.
Because e is both the x. And without the e, you can't have the x.
What's the operator? The operator is sine x. This is the same thing, right? I've just rearranged it slightly. So I'm taking sine x and then I'm raising it to the e. But originally e is raised to the, yeah? So the base function is e to the x. If I'm changing the value of x, I'm putting function in place of it. Yeah? Think of it as if I were to do, let's say, the square root of x. When I say the square root of sine x, when I do the substitution, it's square root x. And then the sine x is inside the square root. So it is the inside function, right? So when I say e to the x, that's my function. When I take x out and put something else in, I got to know what the something else is first and then do e to the x, right? So the inside is what's changing. Are we happy with that explanation? Okay. Oh, you're testing me guys today. All right. New rule. It's on your formula sheet. All these rules are on your formula sheet. Okay. If you have an exponential, it is the exponential. Sorry, this is the backwards thing. If your base is not e, so it's some other number, right, then it is your derivative is the exponential times ln of a. The reason we don't have it up here is because the ln of e is 1, right? They're inverses of each other. So if your base is any other number other than e, the general formula is your exponential as is times the ln of a. So the ln of whatever the base is. Okay. You're ready for a brain break? Can we do one more and then I'll give you a brain break? Okay, here's an inception question again. Okay, let's do it this way. Let's color code it. Sine of u. Let's call this letter H. And then G is cos of V. Yeah, U, sorry. V is tan X. Okay. So F prime is H prime times U prime times V prime. Yeah, we're good? Okay, let's continue. So H prime is cos of U multiplied by minus sine of V multiplied by secant squared X. Okay? So now I have to substitute back a couple of times. Cosine of U is cosine of tan X. Right? Because U is cos V and V is tan X. Are we following that? Okay, so this is that part done. So now I have negative sine of what? What's just tan X, right? And then I have secant squared X. Okay, we're good. So, can we combine? What is secant? Yeah, secant is 1 over, so this is 1 over cos squared X. And I have a cos, I don't have a cos X. Right? This is cos of blah, blah, blah. So I can't cancel out, but I could write it as a fraction. This is cos of tan multiplied by sine of tan all over cos squared X. Yes.
Sign should be negative.
Yeah, I put it out front. You can only combine coses and tans if the inside is the same. Yeah, this cos has all this junk inside, this tan has all that junk inside, and this cos has just the X inside. So none of them have the same inside, so I can't do anything with them. Now, if this was a cos of an inverse cos, those would cancel and go away. But because all of these are regular, then that is what it is. Okay, are we happy with this example? Okay, I'm gonna pause the video, or not pause, I'm gonna stop the video. We can go back to that other example. What about number 12? You can do that. Okay. How about I set it up for you and you guys can do that? F is e to the u. U is secant of v. V is 3 theta. So y prime is f prime, u prime, v prime. So start on the outside, work your way in. Okay. Do you want me to include it on the video so you can go back to it, or can we do it on the board? What do you prefer? Well, it does. What do you prefer? If I do it on the board, you're never going to see it again. Let's do it on the video because then you can always go back to it. Okay. This will just be a really awkwardly long video, right? Example 9. Okay. F is the square root, oops, of u. U is x plus square root v. V equals Are we happy with that line of substitution? Okay. So y prime is f prime u prime v prime. F prime is 1 over 2 root u. Are we happy with that? I hear nobody crying about it, so let's keep going. U prime, 1 plus 1 over 2 root v. Happy with that?
Yeah.
Okay. V prime, 2x. Done. Okay, so now 2 and 2 cancel. And I'm going to put this x just up here in the numerator, right? Because they're just multiplying. And then I'm going to substitute u and v. So this is x root, what is u? X plus root v, x squared plus 1. Multiplied by 1 plus 1 over 2 root x squared plus 1. Is that a cleaner explanation? Okay. So now you've got it on video, so you can record it anytime.